So far, we've talked about how to plot functions on graphs in Learning Target 2, making appropriate scales. We have talked about whether or not a relationship is a function or not in Learning Target 3. In Learning Target 4, we talked about using function notation to write functions. And in Learning Target 5, which is what we're taking notes on today, we're going to talk about how to classify a function as either linear, quadratic, cubic, exponential, absolute value, or a square root function. There are many different types of functions, and in this class, we will mainly focus on those listed in the learning target: linear, quadratic, cubic, exponential, absolute value, and square root. It is important to know the characteristics of each type of function so we can easily tell which type we are working with. On the next page, we can write defining features, and on this page, we can write defining features of these functions so we will always be able to tell which type it is. To do this, we need to remember that the most important thing is what is happening to the x. We are going to make a star by that because that is extremely important. And if you are given a table, you'll be able to plot the points and then look at the graph to decide. So really we just need to think about what these functions look like as graphs and as equations, because if you have a table, you can turn it into a graph by plotting the points. So let's talk about a linear function first. A linear function is any function that has x to the first power as the biggest power. So what makes a linear function? When x is only to the first power. There are no x squareds or x to the third power or x to the fourth power, only when x is to the first power. So remember, if a variable doesn't have anything written up here, we assume that that's to the first power. So what this looks like is we could say f of x equals 3x. That's a linear function because x is to the first power. There's nothing written there, so the 1 is assumed. Or another example would be f of x equals, we'll say, negative 2x plus 3. There's lots of stuff going on, but the most important thing here is what is happening to the x. The x is to the first power, so that is a linear function. Defining features of linear graphs, well, linear graphs look like lines. They look like lines. So some examples are a line, or a line this way, or a line that way. Now, a vertical line would still be a line, but it would not be a linear function because remember, a vertical line would not pass the vertical line test, so it's not actually a function at all. So we'll just do that. Okay? Turn the page. Now let's talk about a quadratic function. Remember that what is most important is what is happening to the x. So for a quadratic function, the x is to the second power. And that's the biggest one. You could have other x's, just even x to the first power. But if the second power is the biggest, it's quadratic. So let's add that. The x is to the biggest, or the x is to the second power. And this is the biggest power. So this could look like f of x equals x squared. Or f of x equals 3x squared plus 4. In both of these cases, the x is to the second power, so it's quadratic. Another example could be f of x equals 3x squared plus 4x. Even though there's an x to the first power right here, because this squared is the biggest power, this is a quadratic function. It's not linear because the squared is here. We're looking at the biggest power. The defining features of a quadratic graph, they look like the letter U, but minus the tail. Just the U. Let's draw it like that. They look like the letter U. So examples of quadratic graphs, they could be a U like this. They could be a U that goes down, upside down U. They could be a really wide U. Or they could be a really skinny U, and even go upside down to be a really skinny U. They can never be a sideways U, though. They can never do this, because that would not pass the vertical line test, and it would not be a function. Okay, so they're never going to be a sideways U. No way. Now what makes a function cubic? Well, just like a cube is a three-dimensional figure, what makes a function cubic is the x has a power of 3, so it is to the third power. And this is the biggest power. There can be x squared, there can be just x to the first powers, but as long as there's a third, it's a cubic. So this could look like f of x equals x cubed. This could be f of x equals 5x cubed, that's cubed, plus x squared minus 3x plus 4. Just making these up. As long as the x is to the third power is the biggest power. So these are hard to describe. One end goes up and the other goes down, but not aligned. So what I'm saying is not aligned because it's curved. One end's going down, one end's going up. It could be doing this. It could be doing this. Or it could be doing this. However, it's not making more, there's no more than 3 pieces. Just like there's no more than 3, it's the exponent, there's no 4th or 5th powers. There's no more than 3 parts. So there's like 1 part, 2 parts, 3 parts. You can't have 1, 2, 3, 4, 5 parts. That doesn't work. A cube looks like this. For exponential, what makes a function exponential? It would be the x is the exponent. Because remember, what's important here is what is happening to the x. So some examples would be 2 to the x power, or equals 3 to the x power, or equals, we'll say negative 2 to the x power plus 1. Defining features of this graph is it never touches the x-axis or some other horizontal line. And it grows very quickly. So what that looks like is maybe let's say in this direction it's never going to touch the x-axis. It's going to get closer and closer and closer and closer to it, but it'll never touch in this direction. And in the other direction it grows very quickly. Or Maybe it gets closer and closer and closer and closer here, but never touches it. And in this direction, it grows very quickly. Or it could get closer down here and go that way very fast. Or it could get closer going that way and go that way very fast. Those are all exponential functions, but it will never touch this x-axis. It will get closer and closer and closer forever, but it will never touch. Absolute value, what makes an absolute value function? The x is in an absolute value symbol. So that looks like this. It's like two bars on either side of an x. And the defining features, or it could also look like this. We'll say, okay, there can be other stuff there also, as long as the x is inside an absolute value. And defining features, these graphs, so they look like the letter V. So they could look like this, or they could be an upside down V, or they could be a really wide V, or they could be a really skinny V. But they always look like V's. And lastly, the square root function. What makes the function square root? The x is under a square root symbol. So that could look like that. Or that could look like, we'll say, 3 square root of x plus 1, all under the square root. There can be other things happening too, as long as the x is under the square root. These graphs have a starting point and then swoop to the right. So they always have a starting point and then they swoop to the right. They can swoop down too. They always swoop to the right. And that is all of the functions that we are going to talk about in this class.